Okay, so section 3.1. Solving systems by graphing. In chapter 3, we're going to talk about something known as system of equations. Anybody know what a system of equations is? A lot of equations, that's correct. An equation is one equation. A system of equations is simply two or more equations. So a system of equations is two or more equations. That's all it is. By a solution, we're going to be looking for solutions. A solution to a system is a point that makes all of the equations true. And that's what we're going to be doing over the next couple days, is learning different ways to solve systems. It turns out there are lots of different ways. We're going to study 3 of them. We'll learn to solve systems by graphing. We'll learn to solve systems by something called substitution. And we will learn to solve by something called elimination. But there are actually other ways. Lots of other ways that I can think of. All right, so here's a system of equations. Y equals 2x minus 3. And y equals 1/2 x plus 4. Why is that a system of equations? There's more than one equation. There's 2 equations. Is 2, 1 a solution to the system? Well, it's a yes or no question. You have a 50-50 chance of being correct. Any guesses? Yeah. Any votes for yes? Any votes for no? All right, well, what does it mean to be a solution? It means that this point, x is 2, y is 1, has to work in both equations. If I plug 2 into the first equation for x, what do I get? Does 1 equal 2 times 2 minus 3? Yes. So it works there. That one's fine. What happens if I plug in x equals 2 and y equals 1 into the second equation? Does 1 equal 1/2 times 2 plus 4? No, it certainly doesn't, because what's 1/2 times 2? 1, and 1 plus 4 is 5. Does 1 equal 5? No. So is that a solution? No, why not? It doesn't work in both of them. To be a solution, it has to work in both. So our answer there would be no. That's not a solution. All right, we'll come back to that example in a little while, and we'll see if we can find the solution. I can't figure that one out in my head right off. So let me give you another example. We'll find one that is a solution. How about y equals 3x minus 1 and y equals x plus 3. Is 2, 5 a solution? Well, without doing any work, your guess should be yes, because if the teacher didn't know the first time, he's probably doing yes the second time, right? So without doing any work, your guess, if you're just going to guess, you should probably say yes. And I think their answer is yes. Why is the answer yes? it works in both of them. If I take x equals 2 and y equals 5 and plug it into the first one, I get 5 equals 3 times 2 minus 1. That's correct. If I plug it into the second one, I get 5 equals 2 plus 3, and that's correct. So our answer for that one would be yes. That actually is a solution that works in both. Questions on that? All right, now let's say I were to take these two equations, y equals 3x minus 1 and y equals x plus 3, and I were to graph both of those equations. What would happen? Would those two lines cross? Absolutely, those two lines would cross. How do you know those two lines would cross?
They both share the same,
Well, we already know they both share one point. They share the point 2, 5. That's correct. What's that? No, they don't have the same slope, do they? What's the slope of this one? 3 over 1. And what's the slope of this one? Well, no, the x value is 2, but that's not the slope. They have different slopes, don't they? The slope of this one is 3. The slope of that one is 1. So are those lines parallel? Definitely not. Those lines are definitely not parallel. So do they have to cross somewhere? Yes, they do. How about the first example I gave? What's the slope of that first line? 2 over 1. And what's the slope of that line? 1 over 2. Are those two lines parallel? No, definitely not. They have different slopes. Are they perpendicular? Yes? No? Maybe? Correct. They are not perpendicular. To be perpendicular, this would have to be a 2, and that one would have to be a negative 1/2. So they're not parallel. Correct. It could also be a negative 2 and a positive 1/2. That would work to be perpendicular also. But what we do know for sure is this one has a slope of 2. This one has a slope of 1/2. They have to cross somewhere. And where they cross, that's what we call our solution. So in a few minutes here, we'll try to figure out where those two lines cross. But let's go back to this one, because I know this one has a real nice answer. Y equals 3x minus 1 and y equals x plus 3. Here's how you're going to solve in this section. You're actually going to graph them. You're going to graph the two lines, and you're going to determine where they cross. How would you graph y equals 3x minus 1? The first one, y equals 3x minus 1. What would you do to draw the graph of that line? The slope is 3, which is rise over run. That's true. But I need a starting point before I can use my slope. The y-intercept is 0, negative 1. How do you know the y-intercept is 0, negative 1? Because we're in y equals mx plus b form. So we start at the y-intercept of 0, negative 1. And then I agree completely our slope is 3. So we go up 3, 1, 2, 3, over 1. And then I can do it again if I want. Up 3, 1, 2, 3, over 1. Draw my line. So this time I am going to label my lines. So I am going to write here y equals 3x minus 1. So I know which line that was. Because we're going to end up drawing more than one. When you draw more than one line, I do think it's important to label your lines. So I know people were asking me about this earlier when we were graphing lines, and I said at this point you don't need to worry about it. Well, now you should. Now you should label your lines like so. And the other thing that helps is using different colors. So I'm going to use red to graph y equals x plus 3. How would I graph y equals x plus 3? The y-intercept is 0, 3. The slope is up 1 over 1. So I go up 1 over 1, up 1 over 1, and I connect my dots. So this is y equals x plus 3. And then basically what you're going to do is you're going to look at your graph. And you're going to say, oh, well, do those two lines cross? They certainly do. And where do those two lines cross? It looks like x is 2 and y is 5.
So you're not picking points like 0, 1, you're just making it 0 and then 5.
Right. Based on the way this equation is written, when the equation is written as y equals mx plus b, I think the easiest way to start is to use this number to have your y-intercept, and then use that number, which is your slope, to just go up and over. If you want to come off to the side and build yourself a little table, you certainly can. There's nothing wrong with that. I just think that at this point, the quickest and easiest way to draw the line is to use the slope and use the y-intercept. So that's what I would do.
Now, if there was a number where y is, it would be right?
Absolutely. So let's try another example. And we'll still come back to that one in a minute. That one we don't know the answer to yet. Where is it? There it is. We'll come back to this one. I haven't forgotten about it. Okay, so let's say I gave you I don't know, about 2x plus 3y equals 12. And y equals, I got to think hard to make it come out so it works to be a nice answer. How about negative x plus 5, I think will work. Well, what we would do is we're going to draw both those lines, and then we're going to look to see if the lines cross, and if they do cross, where do they cross? And that'll be our answer. All right, so we draw our grid. 1, 2, 3, 4, 5. And of course, it's extremely important that we put scaling on our graph this time. It was important before, but it's extremely important now. Why is it extremely important now? So you can see where the lines cross. If you don't have any scaling, it's hard to tell where they cross. All right, so y equals negative x plus 5. Let's do that one first. I think that one's easier. How would you graph y equals negative x plus 5? Start at your intercept. Your intercept is 0, 5. And then your slope tells you to go down 1 over 1. So I go down 1 over 1. Down 1 over 1. And I connect my dots. Second one's, well, actually, it's the first one. The one I wrote first, but we haven't done it yet, so it's the second one we're going to do. Second one's a little harder. How would you graph 2x plus 3y equals 12? Simplify it, and how would you simplify it? Get y all by itself. Okay, that's a good way to do it. So I got to do some work here on this one. 2x plus 3y equals 12. So to get y all by itself, what do I do? Subtract 2x on both sides. So 3y is minus 2x plus 12. And then I have to divide by 3 and make sure you divide by 3 everywhere. Y equals minus 2/3 x plus 4. Okay, now that I have y all by itself, I can graph pretty easily, can't I? My intercept is not 4, 0, rather it's 0, 4. 0, 4, which is right there. And then my slope tells me to go down 2 over 3. And I could do it again. Down 2 over 3. And of course, it would be very useful if I actually had graph paper here so that my scaling was equal and everything came out nice, because I kind of had to cheat a little bit there, I think, to make it look correct. Okay, so now you look at your picture. What's the answer? Where do those two lines cross? It looks like they cross at 3, 2. Am I 100% confident on that answer? No, why not? What would be a really good idea is to try it in both equations. Because like I said, with my graph, my scaling wasn't very consistent. I might be off a little bit. It might actually be 3, 1, or maybe it's 4, 2. My scaling isn't really clean enough to be very confident. So it's an excellent idea to plug the numbers in and check. So if I plug 3 in for x and 2 in for y, I get 6 plus 6, which is 12. So that one seems to work there. And if I plug in here, I get 2 equals negative 3 plus 5. Does 2 equal negative 3 plus 5? Yes. So we do happen to have the right answer. But I think it's a really good idea, after you draw your graph, you think you find where they cross, plug them back in and check. And that'll help. All right, our answer there was perfectly correct. But it's not quite how I would have done it. I would have graphed 2x plus 3y equals 12 in a different way. Anybody remember how I like to graph equations when they look like that? Correct. What I like to do is I like to find the intercepts. So what I would have done to draw this line is I would have built a little table. I would have plugged 0 in for x. If I plug 0 in for x, 2x is going to go away. So 3y equals 12. Y would have to be 4. And then I would flip it. I would plug 0 in for y. If I plug 0 in for y, the 3y piece is going to go away. 2x equals 12. So x would have to be 6. So I would have just drawn 0, 4, 6, 0, and connected the dots. That's why I would have done it. That's my choice. Right. And I would only use that when these numbers come out nice, when they come out to be nice numbers like 4 and 6. If I'd have done this and I'd gotten some fraction or some decimal for either one of those, then I wouldn't have done it that way, because that's going to make my graphing a lot more inaccurate. This is the way, getting y all by itself, that's the way most students prefer. And it's perfectly fine. I just think it's a little extra work. I think it takes longer. So I like to just jump right to the intercepts and figure those out and use that to graph my line. Questions on that? All right, let's go back to that one I had a minute ago. Let's see if we can figure that one out. That one that had a fraction in it. Let's see, it was y equals 2x minus 3. And the other one had a 1/2 in it. Y equals 1/2 x plus 4. We know for sure they have to cross because they have different slopes. So we should be able to find the answer. And the nice thing is, they both have y all by itself, so they're both pretty easy to graph just the way they are. Y equals 2x minus 3. How would you graph that one? The y-intercept is 0, negative 3. And then we're going to go up 2 over 1. Up 2 over 1. Y equals 2x minus 3. Okay. Second line, y equals 1/2 x plus 4. The y-intercept is 0, 4. And then we should go Up 1 over 2. Up 1 over 2. Well, they definitely cross. We can see an answer. What is that answer? Looks like x could be 5 and y could be how much? 6. So 5 comma 6, is that the right answer? Plug them in. If I plug 5 in here, 2 times 5 is 10. 10 minus 3 is 7. So that's definitely not the right answer. It didn't work in the first one. So 5 comma 6 was not the right answer. So now we got to go back to our graph and we got to look again. What's that? 5 comma 7. Well, we know that works in the first one, don't we? Because we already did that. Does it work in the second one? What's 1/2 times 5? 2.5? 2.5 plus 4? 6.5. Not the right answer, is it? Cross it out.
So, I mean, this happens a lot.
Unfortunately, yes. So what we're seeing is this is one of the weaknesses of the graphing method. And this is why we will learn other methods starting on Monday. Other guesses for the right answer?
4, 7, or no, it has to be 4.
You think it's x equals 4? That's believable, right? My scaling's not real good. Let's see, if x is 4, well, let's see. Let's just plug 4 into the first one and see what it would have to be. If I plug 4 into the first one, it would have to be 5, right? The next one has to be 4 comma 6. So that's not right either. So 4 5 isn't right. 4 6 isn't right. Put it in the calculator. Very good. When I was in school, a few years ago, don't laugh. It's mean. When I was in school, the graphing method was not very popular. For this very reason. This problem has an answer. But I don't think the answer are nice numbers. I don't think it's like 4 comma 6 or 4 comma 5 or 5 comma 8 or something like that. There is an answer. But I think it's going to end up being some fraction or some decimal. In recent years, the graphing method has become very, very popular because of these calculators. So let's talk about how we solve on the calculator. We go to y equals. The first thing we do is we make sure that our statistical plots are turned off. Notice mine has one turned on. That's going to give me an error a lot of times. So I'm going to hit enter and make sure that thing is turned off. So anytime you have any little black boxes up there turned on, make sure you turn them off. You type in the two equations. I type in 2x minus 3. I type in 1/2 x plus 4. Type them in just like they look. Zoom 6, which is the standard viewing window where we go 10 to the right, 10 to the left, 10 up and 10 down. Calculator draws a very nice picture. There it is. Now, how do we figure out where those two lines cross? Anybody know how to do that on the calculator? What's that? Use the little arrow? Okay, I could push trace, and I could use the little arrows. Okay, for some reason, I'm not sure why, my projector stopped recording in the middle of class, so I'm going to finish up the rest of the lecture for section 3.1 in the comfort of my own home. Graphing y equals 2x minus 3 and y equals 1/2 x plus 4 and trying to find where they cross. So there's the graphs. And one of the students recommended using trace. So I can push the trace, and I can use my arrows, and I can move really quite close. But I can't get exactly right on that spot. So there's a better way. The better way is to push second, and then the trace button, which gives you the calculate menu. And the calculator can do quite a few things. Value, that would allow you to plug a number into one of the equations. 0, that would allow you to solve an equation equals to 0. In other words, it allows you to find the x-intercept. Minimum and maximum, those are pretty obvious. Those allow you to find a minimum point or a maximum point on a graph if it has it. But there's the one we want, intersect. We want to find where two graphs intersect. Those last two, by the way, are derivative and integral. Those are some calculus topics. So take Calc 1 and I'll teach you all about derivatives and integrals. Okay, so here's what we need. Intersect. It asks us, is that the first equation? Yes, that's the first one I want to use. Notice up in the corner here, it tells us this is y is 2x minus 3. Hit enter. Then it asks, is this the second equation you want to use? And again, notice it is y2 equals 1/2 x plus 4. This might seem a little silly, but the reason it asks you, is this the first equation, is this the second equation, is because you might have more than two equations typed in, and the calculator wants to make sure it's using the right one. So I hit enter again. A guess, I move over and get close, and I hit enter, and there it is, it gives me the answer. So we would say, for the system, y equals, we had 2x minus 3, and y equals 1/2 x plus 4. We would say the solution is x equals 4.6 bar. Oops, just want the bar over the 6. X equals 4.6 bar. Y equals 6.3 bar. Or, even better, write it as an ordered pair. 4.6 bar, 6.3 bar. Okay, so that's how you can use your calculator to solve these systems of equations. And you can use your calculator as long as you first make sure all the equations are written as y equals. If they're not y equals, then you can't type them into your calculator, you can't use them. Okay, I want to do a couple more problems, a couple other things that you're going to see in this section. Here's a nice system. 2x plus 3y equals 6, and y equals minus 2/3 x minus 1. Alright, I'm going to go ahead and I'm going to graph those two lines, and I'm going to check to see where they cross. Make my grid, make my scaling. Always put scaling on the graphs. Oops, the last one isn't so good. That's all right. Okay, for the first equation, since y is not all by itself, I would build a little table. I would plug 0 in for x. So 3y has to be 6. Y has to be 2. And then I would plug 0 in for y, which would give me 2x equals 6. So x has to be 3. So that gives me my two intercepts, 0, 2, and 3, 0. Make a line. Second equation has y all by itself already. So I know how to graph. I find my intercept. That's 0, negative 1. The b number right there. My slope is negative 2/3. So I go down 2 over 3. I could do that again if I wanted to. I'm not going to. I'm just going to draw the line. And we see in this situation, well, we're supposed to see anyway, we have two very special lines. The two lines are parallel. And that will happen on occasion. So when the two lines are parallel, there are two correct answers you can give me. You can write no solution. Or the answer you can give me is inconsistent. Okay, so it's important to know that word inconsistent. You will see that word show up, especially if you go to do the homework out of the book or if you're doing the homework online. The directions very often will say, solve the system of equations or show that the system is inconsistent. So you need to know what inconsistent means. Inconsistent means no solution. Alright, and then the last example. How about 4x minus 2y equals 4, and y equals (2x minus 2). Pretty much the same thing. I would go ahead and graph the first one. In order to graph, since y is not all by itself, I'm just going to go ahead and find the intercepts. Of course, you can get y all by itself if you want to. I just personally think that's more work. I don't like to do it that way. Alright, so for the first one, I build myself a little table. I plug 0 in for x. Minus 2y equals 4, which means y has to be negative 2. And conversely, when I plug 0 in for y, 4x equals 4, which means x has to be 1. 0, negative 2, 1, 0. Second one, once again, y is all by itself, so I can graph. I can use the y-intercept, which is 0, negative 2. That's interesting, right at the same spot. Oops, you can't see that very well, can you? Slide up a little bit here. 0, negative 2. And then I go up 2 and over 1, same exact spot again. I have the exact same line. So what we had here is we had the exact same equation, just written in two different forms. When that happens, there is a word for that. The word is dependent. Okay? So again, when you go to do your homework, either in the book or online, the directions will say, solve the system of equations, or show that the system is inconsistent, or show that the system is dependent. So you need to know what the words inconsistent means. Inconsistent means the two lines are parallel, which means there are absolutely no answers. Dependent means they're really exactly the same line, which means you have an infinite number of answers. Any point on the line is actually an answer to both equations. Okay? So know those words. Inconsistent means no solution. Dependent means lots and lots of solutions. They're exactly the same line.